Welcome to the third and final part of the discussion video for limits involving infinity. In the first and second parts of the discussion, we finished solving items 1 to 7 of this list of exercises. For this video, we are starting with item number 8. So for number 8, we are asked to find the limit of 3 minus x squared all over the square root of 4x raised to 4 plus 1 plus x squared as x goes to positive infinity. We use the same technique as in items 6 and 7 discussed in the previous videos, which is to divide both the numerator and the denominator by the highest power of x in the denominator. In this case, it is x squared. So this is equal to the limit of, copy this function, multiplied by 1 over x squared over 1 over x squared. So dividing, this will be equal to the limit of 3 over x squared minus 1 all over the square root of 4x raised to 4 plus 1 all over x squared plus 1 as x goes to positive infinity. Now at this point, we take note here that x squared is equal to the square root of x raised to 4 for positive values of x. And since x goes to positive infinity here, we can replace x squared with the square root of x raised to 4. But actually, x squared is equal to the square root of x raised to 4 even for negative values of x. But it's good to always check, especially when we are dealing with problems that involve the radical symbol. So this will be equal to the limit of 3 over x squared minus 1 all over the square root of 4x raised to 4 plus 1 over x raised to 4 plus 1. We can further simplify the expression in the radical symbol. This becomes the limit of, copy the numerator, all over the square root of 4 plus 1 over x raised to 4 plus 1. Now as x goes to infinity, observe that these terms will all go to 0. So the limit will be equal to 0 minus 1 all over the square root of 4 plus 0 plus 1. And therefore, the limit is equal to negative 1/3. For number 9, we try to look for the limit of the function w plus the square root of w squared plus 2w as w goes to negative infinity. Observe that the limit is indeterminate of type infinity minus infinity. Since this is indeterminate, we rewrite the function by rationalizing. So we multiply both numerator and denominator by the conjugate of the function. So this is equal to the limit of w plus the square root of w squared plus 2w times the conjugate w minus the square root of w squared plus 2w all over w minus the square root of w squared plus 2w as w goes to negative infinity. Multiplying, we have the limit of w squared minus w squared plus 2w all over w minus the square root of w squared plus 2w as w goes to negative infinity. This simplifies to the limit of negative 2w all over w minus the square root of w squared plus 2w. You can check that this is still in its indeterminate form. Both numerator and denominator go to infinity as w goes to negative infinity. So what we do is divide both numerator and denominator by the square root of w squared. So this is equal to the limit of negative 2w over w minus the square root of w squared plus 2w times 1 over the square root of w squared all over 1 over the square root of w squared. Now we note here that the square root of w squared is equal to negative w for negative values of w. And since w goes to negative infinity here, we can replace the square root of w squared by negative w. And we can rewrite the previous step into this expression, replacing the square root of w squared here by negative w. So multiplying, the numerator becomes 2, and the first term of the denominator becomes negative 1, since we replace the square root of w squared by negative w here, and this becomes the square root of w squared plus 2w all over w squared. We further simplify the expression inside the radical symbol, so we have the limit of 2 over negative 1 minus the square root of 1 plus 2 over w. Two over w here goes to 0 as w goes to negative infinity. So as w goes to negative infinity, this is equal to 2 over negative 1 minus 1. And therefore, the limit is equal to negative 1. Now, on to the last item, item number 10. Let's evaluate the limit of 1 plus the square root of x raised to 6 plus x squared plus 1 all over 2x cubed plus 3 as x goes to negative infinity. Again, we have an indeterminate form of type infinity over infinity, and since we have a rational function, we can once again write this by dividing both numerator and denominator by the highest power of x, which in this case is x cubed. So this is equal to the limit of 1 plus the square root of x raised to 6 plus x squared plus 1 all over 2x cubed plus 3 times 1 over x cubed over 1 over x cubed. Multiplying, this is equal to the limit of 1 over x cubed plus the square root of x raised to 6 plus x squared plus 1 over x cubed all over 2 plus 3 over x cubed. Now, since we eventually want to simplify the expression in the radical symbol here, note that x cubed is equal to negative square root of x raised to 6 for negative values of x. And since x goes to negative infinity in this item, we can replace x cubed here by negative square root of x raised to 6. So this will be equal to the limit as x goes to negative infinity of 1 over x cubed minus the square root of x raised to 6 plus x squared plus 1 over x raised to 6 all over 2 plus 3 over x cubed. If we simplify the expression in the radical symbol, we have the limit of 1 over x cubed minus the square root of 1 plus 1 over x raised to 4 plus 1 over x raised to 6 all over 2 plus 3 over x raised to 3. Now note that as x goes to negative infinity, these terms all go to 0. So this will be equal to 0 minus the square root of 1 plus 0 all over 2 plus 0. And therefore, the limit is equal to negative 1/2. So that's the last item for this discussion. All of these were taken from the Math 21 module, and if you wish to practice answering additional exercises, you may refer to the set of exercises in the module.